All right. So George Boole is the pioneer of the study of logic back in the 1800s. What's surprising is he's one of the pioneers of computer science, even though he lived in the 1800s and there weren't really any computers around. There may be one or two. There was a mechanical computer that somebody was working on. He never got the funding to build it, though. It's really kind of sad. This guy came up with this way of a mechanical computing device and could never actually build it. So they finally did actually build it, and it does work. So that's hundreds of years later. So what's the value of this expression, right? We're talking about conditional expressions. Amount is the amount less than $1,000? You're asking a question, and the answer is either true or false, yes or no, true or false. You can think whatever. In the language, they call it true, and false is the other value. So a Boolean type has one of two values, true or false. But you can use Boolean variables to model lots of different things. Like say if you're doing a coin flip, true could be heads and false could be tails. If you're playing checkers, it could be the black checkers are true and the red checkers are false. Anything that just has two states, you can model using a Boolean variable. It doesn't have to be just for true or false things. It could be this thing or this other thing. Now, inside of our class that we're writing, the day class, we have a few of these predicate methods, like is leap year, the one that we worked on last time. Well, here's one for the bank account class, and is overdrawn. You try to see if the balance is less than 0. Now, if you would call this on my bank account, for example, it probably would be true. Yeah, I'm constantly overdrawn. But so what's interesting about predicate methods is they always return a Boolean value. See right there, that data type right before the name of the method. And that's super important. Now, you can also use conditions, predicate methods inside of if statements as conditions. Since they returned the value of true or false already, you don't have to say if Harry's checking is overdrawn equal true. You don't have to say that because this already returns a value of true or false. So if it's true inside these parentheses, it's going to do the first part. And if it's false, it's do the else part. So, or if, say you look at the character class, it's a class we haven't really looked at yet, but say you were just looking at a single character and you're not looking at a whole string of characters, but just a single character. There's a character class and you can ask the character, hey, is this a digit? Like, is it a number symbol? Is this a letter? Is this uppercase? Is this lowercase? So these predicate methods come in real handy when you're trying to understand the nature of the data that you're working with. You can ask questions about the data and then make choices. The computer can make choices based on what it finds. So if a character is uppercase, you take a char character and you test to see if it's uppercase using the character wrapper class. That will return true or false, and then you know whether it's uppercase or lowercase. Useful predicate methods in the scanner are has next int and has next double. If you want to check to see if there's anything there, but not really advanced, usually you like to look to see if there's something there before you try to process it. And so these are a way you can peek ahead. And this comes from a language called Visual Basic. And they had this ability to peek ahead or take a look at what's in the pipeline coming in. And then you're able to make choices. So what you do is you check to see if there's an int coming in. And if there is, what you do, then you read it and store it in the value of n. Okay, so you see that idiom or that structure happen often, especially when you're doing input into your program. So using Boolean expressions, let's look at Boolean operators. Now we've talked about lots of different types of operators in this chapter. We've talked about arithmetic operators. Those are like plus and minus and all of those. And then we talked about relational operators like less than, greater than, less than or equal to. But here's another type of operator. It's called a Boolean operator, Boolean operators, and they look kind of funny. This one, 2 ampersands in a row. That's like if you look at your keyboard, that's Where's the ampersand? It's there somewhere. Oh, there's, yeah, it's shifted 7. The 7 key, holding down the shift key, you get an ampersand. So if you put two of them together, they have to be right together. They can't have any spaces in between them. That's considered an AND operator in Boolean. Here's OR. Now you go, well, where's this key on the keyboard? This one's kind of hard to find. On a lot of keyboards, if you look at them, sometimes there's a line with a hole in the middle. It's right above the enter key. If you look above your enter key, if you hold down the shift key, that's the key they're talking about. Now that comes from, I guess, Linux or Unix land. It's called a pipe symbol. Sometimes there's a hole in the middle of the line. Sometimes there isn't. But regardless, it's that key right above the enter key. You put two of those in a row, and that means or. This or that instead of this and that, right? And then finally, the last Boolean operator we have is not, and that's really straightforward. Whatever's true becomes false. Whatever's false becomes true. Kind of like politics. But here, the not operator basically is the inversion operator and just inverts it. If the expression evaluates to true, if you put a not in front of it, it'll flip it to false. If the expression evaluates to false, if you put an exclamation point in front of it, a not operator, it transforms it to true. So it's just a way of flipping it back and forth. So here's a nice conditional expression. It's kind of complicated because it has relational operators in it, and then it also has this Boolean operator in it. It says this, and I'll try to read it in English. If 0 is less than amount, and amount is less than 1,000, then you do something. So what are they saying here? Well, the amount has to be between, these look like integers, so it have to be between 1 and 999. This will return true if amount is between 1 and 999. If it's 0, well, 0 is not less than 0. It's equal to 0, so that will fail. Now, in order for this whole expression to be evaluated as true, both sides have to be true with an AND operator. With logical AND, this has to be true, and this has to be true for the whole thing to be true. Okay? Both sides. If either side or both are false, then the whole thing is false. So the only way you can get a true out of this is if this is true and that is true. And then you'll get true coming out. And then you'll do the true part rather than the false part or the else part. Here's another one. Say you wanted to check to see if this string that you have is either the capital S or capital M. So S or M. If it's any other characters, you're going to get false. Now, for an OR to work, it's a little bit different than an AND. Only one of them has to be true for the whole thing to be true. Okay? So if this is true, or if that is true, then the whole thing is true. Okay? So it's a little bit different. You can have one of them being true and one of them being false. The only way you can get a false out of this is both of these are false. Say you had a capital letter J for some reason as your input. Well, does J equal S? No. Or does J equal M? No. So both of them are false. So then the whole thing is false. So the only way you can get a false out of a OR statement is if both sides are false. Otherwise, it's true. All the other ones have one side or both have trues in them, then you're going to get true for the whole thing. Okay, so that's how an OR operator works. Not is really straightforward. Say you wanted to check to see if this letter coming in as our input is not equal to the capital letter S. You just say, if not, input dot equals S, okay? Kind of sound like Yoda there. Yoda always gets his words kind of mixed up. If not, input dot equals S. So if you have something in there like the capital W, well, input dot equals is going to say, well, it doesn't equal S, so that will return false. But then you apply the not operator, and that false becomes true. So now you do the true part. So basically, you're just saying in English, if the letter coming in the input is not equal to capital S, then do the next thing. So notice there's no not equals method. If you need a not equals, what you do is you just call equals and invert it with the not operator. And now you have not equals. So here's our first one, the and operator. If the amount is greater than 0, or if 0 is less than the amount, if that's false, then you just bail. You don't have to do the next one because remember, both of them have to be true. So it short circuits the evaluation, the expression, and it just bails right there. But if that happens to be true, then it checks the next one to see if that's true. And if that's true, then it returns true. Otherwise, it just bails at that point. So that's how an and would look like if you're trying to do it in a flowchart form. And this is or. If this is true or that's true, either one or both, that's not going to happen here because how can it be the letter S and the letter M at the same time? So it can only be one or the other. But if it's neither, then it just goes off to the right. But otherwise, if it was an S or maybe it was an M, then you end up going into the or. So or and are a little different, but they work the same as in English, right? If you say the sky is blue and the sun is yellow, right? That would be, well, both statements by themselves are true. Put them together, the sky is blue and the sun is yellow. Well, that's true, so the whole thing is true. So you said and, right? But let's say the sky is purple or the sun is yellow. Well, if the sky is purple, well, the sky's not purple. But the sun is yellow. So you say, since it was an or operator, only one half has to be true. The sky is yellow. You said the sky is, the sky is orange or purple, I said. Or the sun is yellow. Well, the sun is yellow, so that overrides this being false, and the whole expression evaluates to true if you have an or operator. So that's, I kind of like doing them in English rather than just thinking them in logic. Helps me understand. So we're going to take a look at some of these Boolean expressions and see what we come up with. 0 is less than 200 and 200 is less than 100. Well, we know this is true, but unfortunately 200 is not less than 100. This is an and operation. For you to get a true out of a and operation, both sides have to be true. Well, this half is not true, so the value here would be false. Only the first condition is true. So this, if it were in an if statement, it wouldn't do the true part, it would do the else part. Here's another one. 0 is less than 200 or 200 is less than 100. Well, again, 200 is not less than 100, but 0 is less than 200. And we said or, so only one of these have to be true for the entire thing to be true. So you get true back since the first condition is true. Here's another one. 0 is less than 200 or 100 less than 200. Well, both sides are true. So true or true, well, that's true. Again, the only way to get a false out of an or operation is if both sides are false. Here, both sides are true. That's like overkill because you only needed one of them to be true, but here both of them are true. So you're going to get, so we're testing that. Here's one. A lot of people do this. A lot of beginning programmers do this. They say if 0 is less than 100 is less than 200, like you would do in math class. If you're trying to find a range, you don't do it that way in programming land. The computer will not understand this and probably misinterpret it. It might compile, but it won't work the way you want. So that's the syntax error. The expression 0 is less than 100 is true. So that evaluates to true. How can true be less than 200? Those are two different data types. What the programmer probably intended was 0 is less than x and x is less than 100. Just like up here. Or actually, no, I'm looking at the wrong one. What the programmer probably wanted to say would be 0 is less than 100 and 100 is less than 200. If you're trying to specify a range. Excuse me. Okay, let's look at this one. 0 is less than x, or x is less than 100. Why is this bad? I don't know. 0 is less than x, or x is less than 100. Yeah, so this condition is always true. Why would that be? The programmer probably intended 0 is less than x, and x is less than 100. Why would this always be true? Because if 0 is less than x, then anything that's positive is true, right? Anything, if x is any positive number, not including 0, if any of those, that's true. And then if x is less than 100, well, that goes the other way and takes care of all the negative numbers. And because we said or, that means this will always return true, because one side or the other has to be true. There's no other way around it. So probably the programmer meant to say and rather than or. Probably trying to check to see if you're within this range. And you don't use an or operator, you use an and operator. Here's another one. 0 is less than x, and x is less than 100, or x is equal to -1. So now we have two conditional operators here. The question is, it says here the and operator binds more strongly than the or operator. I didn't know that. I just learned that right now. I thought they were the same. So it's going to do this one first before it applies this one. Okay. The order of operations, you can add that to your chart if you're making a chart, and has a higher level of precedence than or, and so that gets done first. I would have assumed they were at the same level, but they're not. 3 more to go. If not 0 less than 200, 0 is less than 200. So that returns true, but then with the not operator, that inverts it to false. So 0 is less than 200 is true, therefore its negation is false. Frozen equals true. Well, if frozen is a Boolean variable, you don't have to ask that question, right? Frozen is already either true or false. So you can use it directly. You don't have to ask if it's if frozen equals true. There's no need to compare Boolean variable with true, because it's already Boolean. It's already true or false. So you can just say if frozen. The same thing for if frozen equals false, not frozen. Don't say it like that. Say it like that. Then you look like a really intelligent programmer if you do it that way. It's clear to use not then to compare to false. Now, my little niece, her name's Lucetta. She told me she liked frozen things for the holidays. I was going to get her frozen gifts. So I got her a big bag of frozen peas and put it in a gift bag. She didn't think that was funny. I thought it was funny. I think she meant the movie, not the vegetables. I'm kind of a mean uncle that way. All right, so here's some truth tables just to summarize what we talked about. If both A and B are true, then the outcome is true. So A is 1/2 of the expression, B is the other half. The only way you can get true out of an and operator is if both sides are true. Here on an or operator, the only way to get false is if both sides are false. If either one or the other or both are true, then the whole thing is true. And then for a not, for a truth table for a not operator, true becomes false, false becomes true. So not too hard to remember. It'd be good to have these in your mind, because you have to write these sometimes very complex conditional expressions, and it's good to know your truth tables, or at least some of the rules. I remember the English rules. Both have to be true for the outcome to be true. That's and. Both have to be false for the outcome to be false. That's or. And then not is just the inverse. And that's not too hard to remember, I don't think. Now, I used to write very complex conditional expressions, sometimes 6 or 7 or 8 different conditions. And I came up with a technique for taking Boolean expressions and reducing them down to a level so you ask the least amount of questions. And the technique was really popular where I used to work, because this was kind of a breakthrough on my part. And I was able to make our programs work faster because our conditional expressions were as simple as possible and not overly complex. And I would take a very complex conditional expression and I would reduce it. It would still give you the same results. It would just take half the amount of time to do the computation, which when you're doing hundreds of thousands of computations per second, can save you a lot of time. So I've come up with some pretty cool stuff when it comes to conditional expressions that people even use today, which is kind of neat. I always like it when people use stuff I came up with in industry. So using Boolean variables, here's one, a private Boolean married. Say maybe you're getting information about a person. And then you can set the truth values. You can say this, well, married is a Boolean. So if the input equals M, maybe they filled out a form and M means married. So they say, okay, if the input is M, capital M, then they're married. And then we're going to set that. So you can set that directly. Because this returns true or false, you can store that in married, because married is a Boolean variable that can store true or false. And then you can use these. If married, then do this. If not married, then do that. You don't have to say if married equal true, because it's already equal to true or false. If it's true, it's going to do this part. If it's false, it's going to do that part. So there's no need to put the equal operator in there, or the equality operator. Or if they're not married, you can do it that way. Now, this is also called a flag. A lot of programmers call these Boolean things flags. You know, flag is up, it's true. Flag's down, it's false. So you're checking for a flag. In Britain, they call these sentinel values. I don't like that term. We don't use that in the United States. So. It's considered gauche. Gauche. I don't even know how to pronounce that. Gauche. That's how you say it. It's considered gauche to write a test such as if married equal true. Don't do that. That shows that you don't understand Boolean variables very well. You kind of, if I saw that with somebody who was applying for a job and I saw that kind of code, I'd go, maybe they don't understand programming very well. So do it like this. Don't do it like that. And then you won't be gauche. You don't want to be gauche. I'm not very good at French. Spanish, I'm good. French, I'm not good at French. So just use the simpler test, just like that, if married. And it reads really nice in English as well. So what does the statement system.out.println x is greater than 0 or x is less than 0? When does this print false? I guess the only time where x could be greater than 0 or less than 0 at the same time would be if x were equal to 0, right? Well, x is not greater than 0, or if 0 is not less than 0, it's not. So yes, the value of x would be the only way this could print false, because if one or the other of the two sides here are true because of the OR operator, it'll be true. So the only way to get a false out of this would be if x is 0. Yeah, when x is 0. Rewrite the following expression, avoiding the comparison. How would you rewrite this if you don't want to use the equality operator? Well, this one's kind of hard. You're trying to see if it's not a digit. Say you want to make sure that the first letter is not a digit. How can you do this a simpler way? Well, what you can do instead of using the equality operator is you can just invert this. If you want to say it's not a digit, you can just put a not operator right there and get rid of the equal false, and it will give you the same result. If this returns true, the false will invert it to false. Yeah, so the better way to write this would be if not character.isDigit. There's no equality operator. It's faster, it's more efficient, and it reads better too. If it's not a digit. That way you don't have to have predicate functions that say is not digit. You can just have one and just invert that. There's only one of two choices, true or false. All right, so that's everything on Boolean variables. They're kind of weird. And then I'm going to skip this section of the slides on test cases. One, because It's boring. And two, we're writing test cases all the time with our test classes when we write our day class. So let's go look at that day class and see where we are in the coding. I'm gonna go out to Replit. Here's my REPLs, and I go into Java 1. I talk to myself when I navigate. This is the starter. I don't think I want to change that one. I wonder if I've changed it already at all. Oh, that's the class file. How'd that get in there? All right, so yeah, so we finished up on is leap year. Well, that was already there. Okay, so that's is leap year. Then we have our day constructors. That's fine. ToString. We needed this method called toMonthString. So if we look down here, I gave you this as a starting point. What you need to do is add the rest of them. Hopefully you've done that already. But what I want to talk about today is how do you go back from the string to a number? And right now it's just, I've just got it set to -1. So it just reminds me, hey, you haven't finished writing the code for this first. So I have my little to-do here. So I wanted to help you with this one today. So I'm going to zoom in a bit. You can see the code a little bit better. And I'm going to help you get started on translate month. Okay. It's going to have the same structure as this, except we're going to do it differently. We're going to just invert it. So I'm going to grab all this code just as an example, since I've already done that. And we're going to just flip it over. So I'm going to paste it right here. All that code I just copied. Now, the first thing we need is, again, we're going from a string to an int. We're translating that string. Maybe it says January, maybe it says February, and we're converting into a number like 1 or 2. So we get a string coming in and we spit out a number. So we already have our number that we're going to send out. So certainly I don't want it to be a string. That's our output variable, our month number. Now I'm not going to initialize it to -1 because I'm going to go through and we're going to make sure it gets set at the bottom of this thing. So here's our output value. It's going to be month number. Instead of switching on month number, we're actually going to switch on this stir month. And what's interesting here is that you can actually switch on a string, which is interesting, actually. In other languages like C can't actually switch on strings. It can only switch on integers. But here we can actually switch on strings. So we could say, okay, I'm going to say if in the case of January, let's say, then I don't want to turn January into January. I want to turn January into the number 1. So I would replace stir month with month number. To 1. So we're just going back the other way. Okay. That's all we're doing. And then here, if the case is February, right? It's confusing. Then instead of setting that, you're just going the other way. We say month number equals 2, and so on. Then for the default case, if they don't specify a valid month name, then we want to pass back a value that will indicate something's wrong. So here we say month number, and we pass back a -1 saying, hey, this doesn't make sense, right? And then instead of returning the month, we're returning the month number. So we've just translated So frustrating. So we just translated the month string into a number. Okay, that's what that will do. However, there's some issues. I wonder what it's complaining about here. It's got a little squiggly there. I'm not sure why it's doing that. Now it's there. I've moved the squiggly thing. Yeah, I don't know why it's complaining. Okay, so let's give this a try. So I put in the month number. So I put in 3 for March. The day is the 7th. The year 2021. Not a leap year. Yeah, we know that. Invalid month number. Why are we getting that? Invalid month number. It's because of this, right? 2-month string. We're calling that, and we haven't put in March yet. And then also the name of the month is invalid month number. The number of the month is -1. Yeah, so everything is kind of messed up because we used March. Let's try to use one that we actually know. So let's try January. So we do a January 9th, 2021. Not a leap year. There it is, nicely spelled out. So our 2-string method works. The number of days in the month is -1. We haven't done that one yet. The name of the month is January. Hey, it did that. And the number of the month is 1. Cool. So it got the month right. But there's going to be times when you're going to get this input from the user. And what if the user types in lowercase January? Or even worse, maybe the user says, I'm just going to type in Jan. I'm not going to type it. Nobody does that. February especially. They say, I want to abbreviate it. What can I send in the abbreviations? So there's 2 more requirements on this one that we didn't have last time. One is that it needs to be able to respond to both capitalized and uncapitalized versions of the month. And it also needs to be able to respond to the abbreviations as well without the period in them. So the first one you can do is you can say, okay, I'm going to force this stir month, make a copy of it and force it to be all lowercase so that they can type in uppercase or lowercase or a mixed case for their month name, and it still will match this first case. So we would say stir month dot to lowercase. Doesn't really matter which one you choose, just choose one of them. That will make a copy of the string, return it, and now you have the string all in lowercase letters. So then you could just say, instead of capital J, you would say lowercase January. And that would work for any version of January with capitalized or small letters. As long as they typed in January, doesn't matter the capitalization, it will find it. Same thing with February. Okay. So we fixed that first problem. It needs to be able to respond to mixed case. This will force it down to lowercase before you do comparison. And then next thing you got to do is, well, what if they type in the abbreviation? Well, you can just put another case here. You can say case colon, and then you could say Jan. Okay. So if they type in January or just Jan, notice it's lowercase because we've already converted to lowercase. Then they're still going to get the right month number. February. Then you could just add another case. We'll say Feb. Again, all lowercase. Those are colons, not semicolons. And now if they type in February or Feb, then it's going to give them a month number of 2. Okay. Now if it gets through all of these months and it hasn't found a match, then it's going to return -1. Right? We'll just set a month number to -1. Always have a default case. Usually you want to list that last, but Java doesn't really enforce that. So what you have to do with this method is you have to fill in the rest of the month. Okay. What's the abbreviation for May? Anybody know what the abbreviation for May is? Trick question. Yeah, May is the only month that doesn't have an abbreviation, so you just have to put one. What's the shortened form of May? I'm from Mexico. I always like this joke. Hey, when's Cinco de Mayo? I always find that joke funny. It's probably the 5th of May, typically. That's typically when they have it. Okay, so finish this up, this translate month thing. See if you can finish that up. Then what more do we need to do? Let's see. Let's look back at our assignment. Let's see what we've done so far. And static method takes the year as a parameter and tells you whether it's a leap year. We've done that. Add instance variables, month, day, and year as and accessors and mutators. That's already there, so we don't have to do that. Constructor that sets a new date to a specific month, day, and year. Yep, we got that. A method for converting a date to a string. Yep, we've got a toString method. We finished that last time. Given a month number in a year, provide a static method that returns the number of days in that month. Oh, we haven't done that one yet. Use the same switch statement structure used in the 2-month string. So we'll have to do that maybe next time. Here's number 6, a static method to translate the month number into a string that names that month. Yeah, we've done that one already. Okay, so that one's done. So 5 we haven't done yet. 7, a static method that translates the month string into a number. The month string can be a mixed case. I'm also saying it can be abbreviated, right? So we just kind of finished that one. You still have to finish all the rest of the months, but we've got that one working already. So 5 is the only one we haven't done so far. 8, a method that returns how many days it's been since the start of the year for the data object. We haven't done that one. So 5 and 8 still need to get done. Number 9, a method that returns the number of days between this date and another date in the same year. That's another one. So 5, 8, and 9 we haven't done yet. And then 10, a tester that tests all these methods. And the tester's already written. Remember, if we look at I wrote the tester for you. I wonder why it's showing the class files. That's confusing. Here's our tester, right? And it exercises all the methods that we're going to need to do. So you don't have to write that. So that one's done. All right. So going back then, we said that we still need to do number 5 after today, number 8 and number 9. And that's what we're going to be working on the next few days here in class, trying to get those finished up. Now you'll note that I'm not doing all the coding for you. I'm asking you to, I get you started, and then it's up to you to finish the rest of that and make sure it works. Okay? Are there any questions on what the expectation? No? Okay, so this is going to be our last assignment. We're not going to have any assignments after this. So if you want to bolt ahead and do these yourselves without me telling you how to do it exactly, feel free to do that. You don't have to wait around for me. We have some really competent programmers in this group. So if you want to press ahead, please do, and then you can get done early. But if not, if you need a little bit of help, you can, if you miss some of this, and get it out there. And we'll just go through each of these methods until we make sure all of the tests over here on the right all work the way we want. All right. All right. Well, thanks everyone. Have a good rest of the day, and I'll see you tomorrow. Bye. I like to do a game show, like a TV show every day.